Well, again, this is the Pencrest High School AP Physics 1 video series. This is video 9C, Resistivity and Resistance. Now, electrostatics deals with static or unmoving charged objects. We're now going to look at charges that move through a closed loop, otherwise known as a circuit. We usually run charges through a closed loop in order to use the energy that the charges have to perform some function with an electrical appliance. We've already said that when charges move, it is the electrons with the negative charge that undergo the motion. The same rule applies to circuits. Electrons move through the circuit due to the application of what's called a potential difference, which is also known as voltage. We'll get into voltage much more later on. Now, electrical components, appliances or resistors, wire and batteries, they have a characteristic resistance to the flow of electrons through them. This characteristic is called electrical resistance and has the symbol capital R. Resistance is measured in ohms. It uses this symbol here. It's capital omega in the Greek alphabet. Now, all materials resist the flow of electrons to some extent. This property is known as resistivity. It's commonly referred to with a rho. That's this symbol here, Greek lowercase rho. Electrical components have an established length and cross-sectional area. These characteristics, along with the resistivity of the material the resistor is made of, determine the resistance of a particular component. Resistivity is measured in ohm meters. So here's the unit for resistivity. Materials can be considered to fall into one of the categories listed here. We have conductors. These are materials that have a low resistivity and high conductivity. They have many free electrons that flow easily through the material. The resistivity of conductors increases with temperature. So when they get hot, the resistivity goes up, and the resistance to electron flow also goes up. Insulators tend to have a very high resistivity and a low conductivity. They resist the flow of electrons unless the voltage is very, very high. There's a characteristic voltage called the breakdown voltage, in which case the current will arc through the resistor or through the insulator. We also have semiconductors, which are in between conductors and resistors. The tendency for semiconductors is for the resistivity of the material to decrease with increasing temperature. So when the temperature goes up, the resistance actually goes down. We also have superconductors, which theoretically have zero resistivity at some particular temperature that's usually very low. We don't have to worry about them. We're not going to do anything with superconductors. Now, when we have an electrical component, we have an image of a resistor here, connected at either end with wires to the circuit. The resistance of this electrical component depends on the resistivity of the material it's made of, the length of the resistor, and also its cross-sectional area. So here's the formula. It is on your formula page. Notice that the resistance of the component increases with increasing length. So if you make it longer, it has more resistance. But it decreases with increasing cross-sectional area. The area is in the denominator. So a bigger area makes a lower resistance. You can imagine a bigger cross-sectional area makes it easier for the electrons to flow through the material. You could even think of it as a pipe that carries water. A wider pipe would allow water to flow through it more easily. So the analogy is pretty good. Now, if you had two wires of the same material, and we have the same length, but one wire had twice the radius of the other, we would find that the area, the cross-sectional area, depends on the square of the radius. So if the radius were doubled, the area would be multiplied by 4, and the resistance of the thicker wire with the double the radius would be 1/4 that of the thinner wire. Again, we see as the area increases, the resistance of the component goes down. Okay, that's it for resistance and resistivity. Next up is current and voltage. Until then, enjoy, and I'll see you again soon.